All right. Well, I hope you guys are enjoying your vacation, and sorry that we have to do a little bit of studying during break, but don't want to lose too much forward motion in terms of getting ready for that test that's coming up. The semester's almost over, almost did it. So let's go through the first, I believe, 4 questions is what I'm hoping to accomplish in this first video. I think the first 4 are pretty simple questions. I don't think they're going to be too difficult, so let's get going on that thing. So in my first question, it basically just says, hey, is this thing a root or a factor of the problem? So in other words, is 3 a root or is x minus 3 a factor? So we have a couple of options. One of those things is that we could actually use long division, and I know some of you really prefer that long division. Many of you like synthetic division. That's kind of the one that I prefer. I can just execute it much faster. There's a lot less to write down. So remember, in synthetic, we just write down our coefficients. Let's really double check and make sure there's no zeros in there. So I got a cube, a square, a first degree, and then my constant term. So that looks like I've got them all, making sure that I have everything correctly. I drop the 2, 3 times 2 is 6, add down. 3 times negative 1, add down, and then that's going to leave me with minus 3. Now, the question is, was that a factor? And so the answer is no. X minus 3 is not a factor, since there was a remainder. Now, the last little piece is it actually throws us one little teeny extra statement in here, and it says write a summary statement. And I know how a lot of people kind of struggle with what that actually meant. And that means that if you took f of x and you divided it by d of x, what was left over is I had a cubic divided by a first degree. So if I have a third over a first, that leaves a second degree. So that's what this is, which would be 2x squared minus x plus 1, and then this is my remainder, so it would be minus 3 over x minus 3. And normally I write that as a plus, but since my remainder is a minus, then, or a negative, then we're going to go that way. Now, one thing that I personally would love to see you guys do is I've actually put the first few questions in here on my calculator ready to go. So I'm going to double check something and make sure that I didn't make a mistake. So if my table is in asked mode as I have this set up, I can go into here, still have some old stuff from some other questions. I can just hit the number 3, confirm that I in fact did have a remainder of negative 3, so I know I didn't make a mistake. Now, in question 2, it says, let's go through this thing and let's do direct substitution to find out what happens when we do negative 2. So I'm going to just go ahead and ask the question real quick on my calculator. I know negative 58 should be what I'm looking for. So let's find out what f of negative 2 is. Now, I don't for a second think this should be a problem. However, I also know from my experience teaching for way too many years now, that there's a lot of negatives that actually showed up in this problem. And so we do tend to make some of those careless mistakes here and there when we have a whole lot of negatives. So I've got negative 16, negative 28. I'm going to go ahead and pop those together, negative 14. And I saw a negative 30 there and a negative 28 there for a total of negative 58, which, if you recall, is exactly what I saw on my calculator. Okay. Now, it also says by direct substitution as well as using synthetic division. So we'll take a quick look at the synthetic division and see what happens when we divide that. And hopefully that's going to pop out pretty quickly. Drop the 2 and multiply, add down. That's going to give me 26. That's negative 52 and therefore negative 58. We can see that we get the same answer in both cases, which kind of confirms that we did okay. Now, a little quickie reminder is sometimes when we're looking for roots, there's some things that we're going to do. And so in this particular question, I'm not actually going to ask you to find any roots. We're just going to talk about some concepts about that. So Descartes' rule of science literally just asked us to go through here and determine how many roots there are, be they positive or negative. And so if we look at this, Notice it started positive, stayed positive, and right here there's one sign change in there. So Descartes would say that there is one positive real root. Now, Descartes' rule of signs actually says we're supposed to go down by multiples of 2, but since it's literally a count, like a counting number, like how many pens are sitting in front of me, if I have 1 pen, I can't go down to -1 pen. That doesn't make sense. Now, if we looked at g of -x, we could replace x with -x. Now, a negative 4 times is going to be a positive, times the 4 is going to be positive. A -3 times was going to be a negative. A -2 times is a positive, times that is a negative. And then -x times -17 is positive, and that stayed negative. Now, one thing to remember is although this is actually referring to something a little bit earlier, one thing we need to know is that there are 4 complex roots to this problem, and some of them are real and some of them are imaginary. So when we look at that, we should be able to confirm that. We have 1, 2, 3 sign changes, so that is 3 or 1 negative real roots. Also of note is Descartes' rule of signs did not actually indicate what kind. They're not necessarily rational roots. They're not nice. They're just roots. They just work. So keep in mind that we have 4 roots, which is a possibility right here if we have 3 negatives and a positive. Or it actually could be 2 real roots, 1 negative, 1 positive, which would leave us with 2 imaginaries. But we're going to have at least 2 real roots for this problem. Now, in letter B here, it says, let's figure out about upper and lower bound. So that's the one where we were looking to see if the signs, in fact, alternate or not. So in looking at my synthetic division on this set of numbers, I'm hoping, I believe, that this is going to be a lower bound. So if it happens, then these signs coming across the bottom here, these remainders, should alternate signs. And as I go through the process, so far it's looking good. 4 times, making sure I didn't make a mistake here. So far I think we're good. That gives us -27. This is getting pretty large. -44, that's going to give me 132, and therefore 130. So notice the alternation of the signs. Now, so that definitely means this is a lower bound. Now, is it possible that there's another one, like say maybe -2 would also be a lower bound? It didn't say the greatest lower bound. It just said a lower bound. So I know all of the roots here are above -3. Now, in terms of upper bounds, we can check out the number 1. And it was 4, 4, -15, -17, -2. And that's going through the process. It is not a lower bound. I don't need to keep working on this one because I can see already that it is not a lower bound because it did not, neither did it alternate, nor did it actually go all positive. So the last one to check is the number 3. You would probably predict that if the question was being asked that at least one of them would be. So we're starting to grow here pretty rapidly. That's 33. And then we've got 99 here for 82 and 246 for 244. And so this is definitely an upper bound. And I would be actually pretty suspicious that the number 2 is also an upper bound, which would make it the lowest upper bound, but we didn't need to know that. Now, in letter C, we actually get out of that pretty quickly because we know, is there a root between 1 and 2? Well, we already found out that f of 1 was, actually, I guess I didn't finish that one. F of 1, if we finish this, was -26. I actually did finish that earlier. And it turns out that f of 3 was 244. So the intermediate value theorem would indicate that there must be a root in there. Why? Is because it went from negative to positive. So we could say there must be a root on the interval 1 to 3 because f of 1 and f of 3 are different signs. And that's pretty simple, because if you go from negative to positive or positive to negative in a nice, smooth, continuous function, which all polynomials are, you had to pass through 0. So I think let's try to go ahead and do one more piece right here, which is question number 5. This problem does give us a little bit of a get out of jail here, and it says in that we are going to factor this in the linear and the irreducible quadratic form. So if it's a little bit ugly, we don't really worry too much about it. So I know from the possible rational roots theorem that we have the possibilities of 1, 2, 3, and 6 all over 1 and 2. And I want to go ahead and take a look real quick here. And I believe I have this stored in my calculator down here as my third equation. And I do. So I just turn that on. And so I'm going to look at my table and see if I could find some. So 1, 2, 3, and oh, I saw number 2 right there. Let's grab that one real quick. So if we know that 2 works, we can divide that one out. That's going to be 4, 3, 6, 2. Oh, did I mess something up? That's 2x to the 4th. Oh, I missed one piece of it, didn't I? Let's go ahead and fix that. I missed the -1 and the -6 out here. So that's going to be 4, 3. There we go. Now, what jumps out at me almost immediately is you see how all these signs are positive straight across the board? That means there's never going to be any more positive roots because there's no sign changes. So if I went over here and started looking, I'm just going to look at a couple of negatives. So let's see, if I wanted to find another one, not -1 or 2, not -3, oh, I doubt -6 is going to work. So we're going to have to go with some of the fractions. Not -1/2, but -3/2 it is. Now keep in mind, I had 4 roots to find, and I've already found then 2 of them. So if we go through the process and start multiplying, this gives me -3, which is 0. This gives me 0, 2, and then -3 again. And keep in mind that since we just found x minus 2 and 2x plus 3, don't forget we have to divide these coefficients by the number 2, so this really should be 1, 0, 1, meaning that's x squared plus 1, which is definitely what we would deem an irreducible quadratic factor because those 2 roots are going to be imaginary. And so that kind of finishes up our first 5 questions, and hopefully that made good sense, and I think we're going to go ahead and stop that video there. Although I can't stop it quite now because I think my document camera showed up on the wrong screen. So I'm vamping for a moment. Let's keep those changes. Let's stop that share. And hey, we're out of here for real.